Okay, so let's look at some references. If you just make a variable like this, what actually happens is that in your memory, in your computer memory, somewhere, the memory has a lot of addresses, but somewhere in that address, we don't decide that. It's the machine and compiler that decide that, but somewhere we get a variable called x and it will have the value of 3. So somewhere here we will have, the value 3 stored, and the name of that variable will be x, right? So if we then make a reference, and of course you make a reference with the ampersand sign, and when you make a reference you have to initialize it to some value. You're not allowed to just make a reference without saying what it should reference. So we have to say like this, for instance, and then what actually will happen is that this reference is just a new name of this value or of this variable. So actually what happens is that we just get a new name here. So then if I just print it out, of course, yeah, we have to print out y, sorry, like that. So when we run this program, of course, we get the same value twice, because x and y that we print out here and here, they are exactly the same value in memory, so yeah. So this is also why you have to make, you have to decide what value this y should reference. You have to initialize it to reference something, because it's not allowed to just make a name without any memory address. So you have to make, it reference something. So anyway, now these two are totally equal. So what is the point of making this? Well, in this scenario, it isn't that valuable. But of course, now I can say y equals to 7. And now I changed both, because what happened now is that y is set to 7. And then, of course, x is set to 7 also, because it's the same place in the memory, the same value in the memory. So this isn't that valuable, but so the point of using references is usually with functions. So if I now make a function, and then I just send in some value here, n in for number in, like this. I have a function, I send in a value, I print it out. So if I down here use this function and I send in my x or y, doesn't matter because they are the same, what actually happens now is that this function gets called here. Here it says, okay, I have to make a new variable called this. So somewhere in memory, like for instance here, I get the name n in. And then, the value of what I set here is sent into this new variable. So right here, both x and y are equal to 7. So what happens here is 7 is sent into this. So 7 is sent in here. So the value here is 7. And then, of course, this will print it out, and then we return down here, and then this will run. So if we look at the code, of course, this function print out 7, and then we print out the x and y values. But what actually happens is when this function gets called, a new variable is made in memory. So somewhere in memory you have to clear, you have to ask for the operating system to make a space for this memory. You copy the value from this to this, and then you run your function, and then when the function is over, when this sentence is ran, then this will be deleted again. So you saw that we actually made a copy of this value in memory, and that is somewhat slow. So actually it is quicker to make a reference. So if we make an ampersand here instead, now we make a reference to whatever is sent in. So when I come down here and I call this function, I send in this value, but now it says, okay, I'm just going to make a reference to whatever is sent in. So what we have now is that we get a scenario like this. I just get a new name of the same value on the same address in memory, and this is quicker. So this is actually a quicker way to run this function than to have it without, because then it will make a copy. Then I will have, have it like this. And then when the function is over, it is cleared again. So that's one of the main benefits of using references. It's quicker. The other reason to use a reference is we can actually change the content of this value or this variable inside my function. So if I now make another function, really interesting functions, I know. So again, I say int and in, so I send in an integer, and I say now that n_in equals n_in plus 5, right? So that's my function. I add 5 to whatever I sent in. And again, if we then call this function, right, add 5, I send in x is sent in here, but again, the value of x is 7, and I get a new variable named this, and then inside of this it says n_in equals n_in plus 5. So, okay, so I get here 12. But then when this function is over, this is deleted. So you saw nothing happened with my initial original value here. But then if I use a reference here, I can actually use this as a kind of a return type, because I actually send in the reference. So now again, when I call this function, I get a new name on this memory slot, on this value. So when I run this function now, n_in equals to n_in plus 5, okay, it's this value that I change. And then the function is over, and then this name, this reference get deleted, but this is still valid. So when I now run this function, this will say 12. But if I send it without making it a reference, it's still 7, because in this scenario I just make a new value somewhere in memory, and when the function is over, the whole value and the whole variable is deleted. So that's another really good reason to use a reference. And then we can actually expand this even further, so we can actually have use this to have several return types or return values from one function, because as you know, if I say make this function to actually return something. So I can say return this, so it actually returns my value. So now I can have it like this. You know, I send in, I make a copy of whatever sent in, I add to this, but then I actually return my value here. So it gets returned here. So I can now say, just to use this value, I can say cout like that. Now I call this function, this is made, so somewhere in memory, you know, and in is made, the value sent in is initially 7, because we send in 7 here. Inside of this, and in this value is, you know, is increased with 5, so this value gets 7, of course. Now sorry, this is of course 7 now, because if we just look at this, you know, here x and y get 7, so now this is correct. Okay, this initially is 7, but then after we run this, this is 12, and then this whole function returns 12. And here down in my program, whatever you know, what I do with this is actually I print it out here. So this is just a regular function call with a regular return value. But if I actually want several numbers to be returned from my, a function, then I can use references. So if I just make this make this back to the same again, like this. So if I now just have, if I just, I'll get rid of this y also, because now we have to explain that, so I don't have this anymore. But now I get an x value, and I actually make int a equals to something. Yeah, so somewhere in memory, and now, I delete this also, because now we have made our point with that. So we have the value of 3 with x, and then somewhere we have a value of 2 with the name of a. Right? So now I can make a function that actually takes 2 input parameters. Clean this up also. So I can say that my function should actually take an input a and an input b, and then I fix this also to say that in a is increased by 5, and then in b is increased by 5, you know. And I send also this value in by reference. So now I can say, I can call this function like this, and then I just print out a. So initially we have x and a with 3 and 2, but then this is called, and then my first value here, you know, my first variable gets a new name or additional name in a, and then my second variable is have this new name in b. So you see here that you know, in a is increased by 5, so this is increased by 5, and then also this is increased by 5, so this gets 7 equal to 7. And then after this function is run and it's over, then these are deleted. But you see my initial variables are actually changed. So what we managed to do is that we actually have a function that returns or changes two values. You know, this is a really simple function that doesn't do anything insane, but you know, this could be do for whatever. You know, we could have a like a vector, so we send in two values, that is the two values of the vector, and inside here we calculate something with that vector, and then you know, these two values, and then they are actually returned because we sent them in as references. So that's another case that references are really useful. We can actually have several return values from the same function. Yeah. Then just one you know, small detail. If you actually make a function and you really don't want to change it, you know, you want to use this as a speed, you know, like if we look at this function again, I want to use a reference here because I want the speed of using a reference instead of using a copy like this. So what you then can do, just to make sure that you don't change it, because here I can say, you know, I can here I can change it, and in plus equals 3, or again, you know, just to make it easier, I just make it like this. So whatever I send in, I'm changing it to 3, and then I print it out. But if you want to make a function that you know, you make sure that, you know, if a function is called print value, it you know, it hints that it shouldn't change anything, it's just print it. But we want to use the reference to have this function run faster. Then what we do is we say const here. And what that this means is that we send in this value. We can make it like you know, a regular variable, but here the point here is we make it a reference. So here we send this in as a reference, and then if we just call this function print value, and then we send in our a. Since I marked this as const, we're not allowed to change it inside here, you know. So this const is put in because I, you know, when I make this function, I know that I want this variable not to change. You know, that's the point of my function. I don't want it to change. So this is a contract then, you know, that I claim, or I tell my compiler, don't allow me to change this value inside this function. And now you see I get this error message. So I'm not allowed to do this anymore. So that's really useful when you use references for speed, but you want to make sure you don't accidentally change the value inside it, inside a function. Then you put the const keyword here. So this is the way to do it if you make use of references with speed in mind. And this is if you make it with, you know, you want to have these as return values, use them as return values, or you actually want to change them when you call this function. Okay, just the last little tiny thing, if we just run this program now, we see we print out my a here. That's the whatever, that's the only thing I do now. But a tiny little detail at the end here. If you actually use the ampersand, you know, when we use the ampersand, when we make a variable, we make a reference. So when we make a variable, we make a reference by using an ampersand. But if we use a variable, here for instance, we use the variable x and we use the variable a. If you actually put an ampersand before this, so here I use the ampersand when I use a variable, then this ampersand means operator of, I'm sorry, it means address of. So if I print this out, I get the actual memory address of a and x. So here we actually get the address of x and the address of a, and of course yeah, this is wrong because I changed so no, it was correct. So here I get the address of the x and the address of the a, and those are different. But if I just to make this as an exercise, if I now make this y again that we had initially, so now I make a new name of the same place as x. So I have two names of x. If I now print out x and y, but I print them out as address of, I find the address of x and the address of y, then of course we should get the same address. So here you see the address of the memory x and the address of the memory of y is the same, because they're just two names of the same value. Okay.